This is Business Analytics Using Forecasting. I'm Galit Shmueli. In this last set of videos, we're going to talk about how to include external information into our regression models. Up to now, we looked at how to use the history of a time series and use that to project it into the future. We explore different patterns within the series, and then we use those to say something about future values. In these two videos, we're going to look at how to include external information into our models. The goal is to improve our forecasts over our previous methods. There are a few questions that arise. For example, what types of external information can we include? Another question is, which of the forecasting methods that we saw can actually be used? Then there's the question of how to integrate the information into our methods. And finally, don't forget to ask yourself, is all this extra complexity actually worth it? We're going to explore these questions next. There are different types of external information. The first one is special dates. That includes things like holidays, special festivals, sporting events, or any type of event that we know usually in advance about its date. Another related type of external information is historical outliers. This means some values of the series that are very, very unusual that happened in our series. Sometimes we know why and sometimes we don't, but at least we can identify them and know which dates they happened on. What's common to these two types of data types is that they're usually known and that they cause irregular patterns. We will talk about these two types in this video. In the next video, we'll talk about a different type of external information, which relates to external time series. They can either be a causal series that causes our series, or it can be another series that's simply correlated with a series that we're trying to forecast. What we're going to look at is how to include each of these different types of information, and then of course we'll have to ask ourselves, is it worth it? In this course, we saw several types of methods. We saw a range of smoothing methods, including the moving average, exponential smoothing algorithms, and we also saw linear regression models for capturing trend and seasonality, as well as autoregressive and ARIMA models that capture autocorrelation. Only the regression and ARIMA type models can be used to directly integrate external information by adding that information as additional predictors in those models. We'll start by looking at what we call irregular patterns that are either explained, such as holidays, or maybe they're unexplained, maybe they'll be explainable in the future. This includes outliers, or extreme values that we see in our history. It includes, again, special events, and it also includes a third type, which is interventions. Sometimes you have a promotion that's going on that will change the behavior of our sales series, for example. Or maybe there's a policy change that will change the usage of electricity, for example. And we want to include this information into our model so that we can modify our series and our forecasts accordingly. There are different solutions to try and approach this. A simple solution is just to remove these periods. And if we're using a regression model, it's okay to have holes in our series as long as we make sure to skip the T index, which counts the years or the days or the months, accordingly. The other option is, for example, to separate holidays from non-holidays and have two separate series and model them separately. That is also usually a practical solution. And the third solution, which we'll look at more closely in this video, is to keep these or build them into our model by adding dummy variables into a regression model. Let's see an example of including special events in a regression model. Recall the data on type A MRT trips. Suppose that we aggregate the daily data that we had into monthly data, so that our time series is the total number of trips on MRT each month. Look at the time plot. The month of February seems to be a low season. This is marked by the orange color. But are Februaries always low? From a careful look, we see that in some years the pattern is different and February is not as low as usual. If you're familiar with the Chinese calendar, you might suspect that this is due to the Chinese New Year holiday. Because the Chinese calendar is a lunar calendar, this holiday falls sometimes in February and sometimes in January. So we might want to include the external calendar information about the dates of the Chinese New Year holiday each year. We now color the series so that the orange color denotes a month that includes the Chinese New Year holiday. And we can see that indeed this new coloring nicely captures the low traffic on every year. Let's see how to include the holiday information into our regression model. We start by creating a new dummy variable called CNY, or Chinese New Year, which takes the value 1 if the Chinese New Year took place in that month, and 0 otherwise. We then include this CNY dummy as an additional predictor in our regression model, in addition to the linear trend and monthly seasonality predictors that we already have. Including the holiday dummy into the model in this fashion assumes that on both holidays and non-holidays, the series has the same trend, meaning the same slope, and the same seasonality pattern. The holiday and non-holiday series can only differ by a fixed amount, in this case, by a fixed amount of passengers, or trips. Here's a chart of the values predicted from this regression model. You can see that the orange holiday months are nicely captured by the model, whether the Chinese New Year falls in a January or on a February. The same approach that we just saw for a holiday can also be applied to outliers in our data. Specifically, we can either remove the periods with an outlier, or we can replace them with forecasts or impute them, as we discussed earlier on, or we can include them as a dummy variable that's called outlier and include it as a predictor in the regression. Here's another common type of external information that can be included into a regression model. Suppose that during the period of our time series, there was some intervention or policy change that we think might affect the series behavior. For example, a special discount that affects sales, or a power cut that affects electricity usage. In such cases, assuming that we know the dates of the intervention, we can create a dummy variable called intervention, which takes the value 1 during periods when the intervention took place and 0 otherwise. For example, if at time t star there was a policy change, we can create an intervention variable that takes the value 0 before time t star and 1 from time t star on. Note that this type of model assumes that the intervention effect is fixed. It increases or decreases the values of our series by a fixed amount, regardless of other components such as trend or seasonality. We can also model an intervention that has a multiplicative effect. We can use the logarithm of our series as the outcome variable, when values after the intervention are expected to be larger or smaller by a factor compared to the pre-intervention. We saw how to integrate information on special dates, outliers, and interventions. In all these cases, we know the timestamps of these special periods and can therefore integrate them into our regression. We can either model them separately or we can remove them altogether. In the next video, we're going to look at a different type of external information and see how to integrate causal or correlated time series into our own time series through a regression model.